For today's notes, we're going to be learning about properties of parallel lines, and our theme is adorable, cute little puppies. In this video, you're going to be taking basically some proof notes up here on the top. Then you'll be doing a short proof, and at the very, very last slide, you'll be copying down Theorem 3-4 at the very bottom. I would reserve maybe 6 lines at the bottom. So at the top of your paper, I'd like you to write, if two parallel lines are cut by a transversal, then what I'm really going to be doing is going over one postulate, one theorem, and another theorem. All three of these items, postulate, theorem, and theorem, all start with this sentence. If two parallel lines are cut by a transversal, then, here's your first one. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Then the corresponding angles are congruent. And this is what it looks like. Let me move that over, move our puppy down. So here are your corresponding angles. That's one example of corresponding angles. Those are congruent. For our second theorem, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So that's another pair of angles that are congruent. Let's move our puppy out of the way. All right, here's an example of alternate interior angles, and what do you know? Those are also congruent. Our last theorem says if two parallel lines are cut by a transversal, then the same side interior angles are, what do you think, congruent? Nope, supplementary. Supplementary. Okay, let's see. All right, let's move our cute puppy. Oh, that one's cute. Over here. I'll move this over a little bit. Here we go. So here's an example of two same side interior angles. We'll call them angle 1 and 2. Angle 1 and 2 equal 180 degrees. They're supplementary. Below those theorems, I'd like you to copy this proof. It says, given that K is parallel to N, prove that angle 1 is congruent to angle 2. And of course, you're going to need to copy this diagram as well. And of course, S is statements, R is reasons. You can use that abbreviation for you. And what I'd like to show you are that this has 4 steps. And I would like you to try to see if you can do these if I give you the statements. I'll move our little Halloween puppy out of the way. If I gave you the statements, could you give me the reasons? I'd like you to pause the video and see if you can fill in the reasons, and let's see which ones you got right. So you should have paused the video. Let's see what you wrote. Obviously, for our first line, the reason is given. For our second step, angle 1 is congruent to angle 3 because vertical angles are congruent. Isn't that almost always the case? Congruent. All right. Move that over. But why are angle 1 and angle 2 congruent? This is one of those theorems, and this is what it says, and yes, you have to write this whole thing for a reason. Here's how it goes. If two parallel lines are cut by a transversal, yep, that's how it always starts. If two parallel lines are cut by transversal, then angle 1 and 2 are alternate interior angles are congruent. Did I spell that right? Yeah, I did. Here we go. Let's see if I can get that whole thing in. All right, make that a little bit smaller. All right, so here's the whole theorem. If two parallel lines are cut by a transversal, oops, I spelled that wrong, then the alternate interior angles are congruent. Let me fix that. Transversal. There we go, I spelled it right now. Okay, last but not least, why are angle 1 and 2 congruent? Why they're congruent? Because the congruency is transferring through one to the other. That's the transitive property of equality. And that, my friends, is it. Wait, there's more? Oh, yes, there is. Last but not least, and I saved this for you. I know you're like, what? In those last lines that you saved, we're going to copy Theorem 3-4. And just because I care about you guys, I'm going to show you another cute puppy. And you know who that is? That's my puppy. That's my puppy Peanut. That's how he looked when he was a baby. Isn't he cute? I know. All right, let me go ahead and copy this diagram, and while you're copying it, I'm going to write the theorem out, and then we'll go over how the theorem connects to that diagram. Here's what it says. If a transversal is perpendicular, to one of two parallel lines, then, so there's the conditional, then it is perpendicular to the second line 2. Not goo, 2. There we go. Okay, so here's what this means. There's a transversal, and here it comes down, and that transversal is perpendicular to this first line. Well, if it's perpendicular to the first set of parallel lines, then as it continues and turns into the red line, then it's perpendicular to the second line too. This is another theorem that I hope that you study.